Welcome to the deep dive. Today, we're going to be tackling a question that's been a real head scratcher for ages, I think.
Yeah,
How can we reconcile the idea of a world that exists out there, independent of us, with the fact that, all our knowledge always seems filtered through our human perspectives?
Mhm.
It's a bit like asking, is reality really real or is it all in our heads?
It's a classic philosophical puzzle with huge implications, I think, for how we understand science
Mm.
and knowledge and even our place in the universe.
Right.
Luckily, you provided some really interesting source material that digs into this, exploring arguments from both sociology and philosophy.
Exactly. We've got excerpts from a book on science studies that looks at how social factors shape scientific knowledge,
Okay.
which got me thinking how much of what we consider objective truth is actually influenced by the people involved.
That's where the sociology of scientific knowledge, or SSK,
All right.
comes in.
Okay.
It argues that science isn't created in a vacuum. Scientists are real people working within communities with their own biases, assumptions, and historical baggage.
But wouldn't that make science seem totally subjective? Like, couldn't anyone just claim anything is true and it wouldn't matter?
That's a common concern. But SSK doesn't say that anything goes.
Okay.
A key figure in this field, David Bloor, argues for residual realism.
Residual realism.
It's the idea that even though we can't definitively prove the external world exists, it's a reasonable assumption to make for scientific practice.
Okay, that makes sense.
Yeah.
If you don't believe there's something out there to study, why bother experimenting in the first place? But how does this residual realism play out in actual scientific work?
Well, Bloor uses a fascinating case study, the Millikan-Ehrenhaft controversy,
Okay.
to illustrate this point. In the early 20th century, physicists Robert Millikan and Felix Ehrenhaft were both trying to determine the charge of an electron.
Right.
They used similar experimental setups and observed the same phenomenon, but arrived at different results.
Wait, how is that possible? If they're observing the same thing, shouldn't the conclusions be the same?
You'd think so, right?
Yeah.
But that's where social context comes into play.
Okay.
Both Millikan and Ehrenhaft had their own pre-existing ideas about the world and how to interpret the data.
Right.
Ultimately, Millikan's conclusions were accepted by the scientific community,
Okay.
while Ehrenhaft's were dismissed.
So it wasn't just about pure observation.
Yeah.
There was a human element shaping their conclusions.
Exactly. Bloor argues that while nature plays a necessary role in shaping knowledge,
Right.
it's not the whole story.
Okay.
The different conclusions reached by Millikan and Ehrenhaft can't be solely attributed to nature, but also to their different social contexts.
That's fascinating. It challenges this notion of science as purely objective.
Right.
But how does philosophy fit into this conversation? Does it offer a different lens through which to view this problem?
It absolutely does.
Yeah.
Heidegger's philosophy, particularly his concept of being in the world, provides a unique perspective on our relationship with the world.
Heidegger, known for his challenging ideas. I'm intrigued, but also a little intimidated.
He can be a bit dense,
Yeah.
but bear with me, his ideas are really relevant here.
Okay.
Heidegger argues that we don't encounter the world as detached observers standing apart from it.
Right.
We are always already embedded in the world,
Okay.
actively engaged with it,
Right.
and giving things meaning through our interactions.
So it's not just about passively observing things as they are, but about how our active engagement shapes our understanding. I'm starting to see the connection.
Precisely. Heidegger distinguishes between a thing's existence and its essence. To clarify this further,
Existence versus essence.
Yeah.
Break that down for me.
existence is simply the raw fact that something is,
Right.
it exists plain and simple.
Yeah.
But essence refers to the meaning we give it, its qualities, how we categorize it. This essence is always constructed through our interaction with it.
So connecting this back to Bloor and SSK, Bloor's residual realism aligns with Heidegger's idea that things can exist independently of our knowledge of them.
Right.
But the meaning we give things, their essence, that's where social and historical context comes into play.
You've got it. It's a really elegant way to bridge those seemingly opposing viewpoints.
Mind blown. Do you have an example to make this a bit more concrete?
Think about a door.
Okay.
It simply exists,
Right.
but its meaning, whether it's a barrier, an entrance, an escape route, even a portal to another dimension, that's all determined by how we engage with it, the context in which we encounter it.
Great example. I'm beginning to see how our interaction shapes our understanding of the world in a way I hadn't considered before.
And this is just the tip of the iceberg. Heidegger has this fascinating concept of mathēsis, which he argues is a defining feature of early modern science.
Mathēsis. Sounds math-related. Is
Yeah.
this about science becoming all numbers and equations?
It's related but more nuanced.
Okay.
A thesis involves moving from a general, vague understanding to a more specific, precise one.
Okay.
It's not always about quantifying everything, but rather gaining a clearer and more formalized understanding of the world.
So it's like moving from knowing a phenomenon exists to really grasping its essence.
Exactly. Heidegger argues this is what scientific progress looks like, making things more intelligible,
Okay.
more clearly articulated.
That would be a game changer for science.
Yeah?
Got an example of this in action.
Heidegger himself doesn't offer many concrete examples.
Okay.
But think about early metallurgy,
Okay.
the development of standardized techniques for smelting metals, figuring out the exact temperatures, times, and processes needed to get consistent results. That's mathēsis in action.
Great point. It ties into the idea of early modern science aiming to control and manipulate nature to understand its underlying principles.
Absolutely. By carefully controlling the process, we start to see the principles at work.
Okay, this is starting to click, but I'm ready for more. What else does the source material have to say about this?
Let's talk about the Galilean first thing.
A first thing, like the first thing Galileo discovered.
Not exactly.
Okay.
Think of it as a blueprint for understanding how objects behave in the world.
Right.
It's the idea that things are fundamentally governed by universal laws, like inertia,
Right.
what Newton later formalized in his first law of motion.
Yeah.
Things have a natural tendency to keep doing what they're doing unless something external acts on them.
So it's about seeing objects as law-abiding and independent.
Yes.
I can see how that's a big shift in thinking.
Absolutely. And this is where the scientific experiment comes in.
Mhm.
According to Heidegger, the whole point of an experiment is to isolate a thing from external influences,
Okay.
create a controlled environment where you can see its true nature, its essence, in action.
So you're taking a thing out of its everyday context and manipulating it in a very specific way to reveal its hidden principles. That connects back to that idea of mathēsis we were just talking about.
Right on track. It's all about moving from that vague sense of existence to a much more specific and formalized understanding of essence.
It's all starting to come together. I'm guessing there's more to this story.
Oh, absolutely. To see this in action, let's delve into a historical debate that perfectly showcases this shift towards a mechanistic worldview in early modern science. The Boyle versus Line debate.
A classic scientific showdown. I'm ready.
Picture this. It's the 17th century, and scientists are trying to explain this phenomenon called the Torricellian effect, basically why mercury stays suspended in a barometer.
A barometer! That thing that measures air pressure. What's so mysterious about that?
Well, back then it was a big deal. There were two main competing explanations.
Okay.
Robert Boyle, a key figure in developing modern chemistry, argued for his spring of the air theory.
Spring of the air. I'm picturing a giant slinky made of atmosphere.
Ah, I love the image. Boyle's theory essentially said that air pressure pushing down on the mercury in the container keeps it suspended. But Francis Line, a Jesuit scientist, had a different explanation. The funicular hypothesis.
Funicular, like a funicular railway. What does that have to do with mercury?
Line's theory proposed an invisible thread preventing the mercury from falling.
An invisible thread. Sounds a bit far-fetched.
It does, doesn't it? But that's the point.
Okay.
Boyle's explanation was about the mechanical interaction of particles, a tangible and measurable force.
Right.
Line's theory relied on a mysterious, intangible force,
Okay.
not easily quantifiable or controllable.
I see where this is going. Boyle's approach seems to fit much better with that emerging idea of the Galilean first thing, where things are governed by clear, universal laws.
Exactly. And that's what made Boyle's explanation so appealing to the scientific community.
Okay.
It wasn't just observation. It was about finding an explanation that fit with this new blueprint for knowledge.
So, spring of the air wins. Case closed, right?
Well, not so fast.
Okay.
Remember that social dimension we talked about earlier?
Right. We can't forget about the social side of things.
It plays a big role here, too.
Of course. There's always more to the story. Didn't those historians, Chabin and Schaeffer, argue that Boyle's approach also aligned with the social and political climate of the time?
Exactly. They argue that Boyle's approach wasn't just considered more scientifically sound, but it also fit in better with the emerging social order of the 17th century.
Okay.
This was a period that valued control, predictability, and a mechanistic understanding of the world.
So Boyle's theory wasn't just reflecting how things are, but was also shaped by the social and political context in which it emerged.
Precisely. And this brings us back to that initial question of reconciling a mind-independent reality with the social construction of knowledge. It
Right.
seems they're not mutually exclusive.
I'm starting to see the light. So what does this all mean for us? Are we stuck in a world where truth is just whatever the most powerful people decide it is?
Not necessarily. The fascinating thing is, even though we can't fully escape social and historical influences,
Right.
acknowledging them allows us to be more critical and discerning consumers of scientific knowledge.
Okay.
It helps us ask better questions.
Like who benefits from this explanation or what assumptions are being made here?
Exactly. It helps us see the complexities and nuances, the human element,
Yeah.
in a field often presented as purely objective and absolute.
This is a lot to digest. I feel like my brain is getting a workout with all this new information.
Yeah.
But I'm ready for more. What other insights does our deep dive have in store?
Well, since you're really interested in how our understanding of the world is shaped by our interaction with it,
Right.
let's dive a bit deeper into Heidegger's perspective on that.
Yes. More Heidegger, please. I'm ready to level up my philosophy
All
skills.
right, challenge accepted. Remember how we talked about mathēsis as a process of moving towards more precise and formalized understanding?
Right.
Heidegger argues this is a defining feature of early modern science, a shift away from the more qualitative and holistic approach of earlier periods.
So it's not just about observing the world anymore, but about actively manipulating it to uncover its hidden laws.
Precisely. And Heidegger points to Galileo as a key figure in this transition.
Okay.
He introduces the Galilean first thing, which is essentially a blueprint for understanding objects as fundamentally law-abiding and autonomous.
Okay, remind me again what's so special about the Galilean first thing.
Imagine an object completely isolated from all external influences,
Okay.
just existing in a state of pure motion or rest.
Right.
It's the Galilean first thing. An idealized concept of an object governed solely by its internal principles, like inertia.
So it's like a thought experiment, stripping away all the messy complexities of the real world to see the underlying laws at work.
Exactly. This idea becomes the foundation for the modern scientific experiment.
Okay.
The goal is to create a controlled environment where you can isolate an object and observe its true behavior, its essence, without external factors interfering.
It's like we're not just passively observing the world anymore. We're creating artificial situations to force nature to reveal its secrets. That's a pretty powerful concept.
It is. Heidegger argues this shift is directly linked to the rise of mathematics as the language of science.
Right.
By using math to describe the behavior of these idealized objects, we can formulate universal laws that apply to the world.
This makes me think about those early experiments we discussed, like with the Torricellian effect and the barometer. Boyle's spring of the air theory, which was all about air pressure as a measurable force, really embodies this approach, doesn't it?
It absolutely does. Boyle's explanation was based on the idea of air being made up of tiny particles,
Yeah.
constantly in motion, exerting pressure on their surroundings.
Right.
That's a very mechanistic way of understanding the world,
Yeah.
very much aligned with the Galilean first thing.
In line with his funicular hypothesis and that invisible thread just didn't fit into this new paradigm.
Right.
His explanation was too qualitative, too reliant on forces that couldn't be easily measured or controlled.
Right. And that's a key point. It wasn't just that Lyon's theory was wrong, but that it didn't align with the emerging scientific worldview.
Right.
This new way of understanding the world as governed by universal mathematical laws.
Okay, so the shift toward this mechanistic worldview was a game changer for science.
It was.
But we can't forget about the social side of things, right? Didn't we say that historians Chapin and Schaeffer argued that Boyle's approach also happened to fit nicely with the social and political climate of the time?
Absolutely.
Yeah.
They point out that Boyle was part of this emerging scientific community, the Royal Society,
All right.
which was very invested in promoting a view of the world that was ordered, rational, and predictable.
Okay.
This was a period of intense social and political upheaval,
Right.
and this new scientific method offered a way of making sense of the world that felt stable and reassuring.
So Boyle's success wasn't just about being right. It was also about his ideas resonating with the values and anxieties of his time.
Exactly. And this is where the idea of a mind-independent reality gets really tricky. It's like, we can't deny there's a world out there,
Right.
but the way we understand it, the questions we ask, the explanations we find satisfying,
Yeah.
all of that is shaped by our social and historical context.
Wow, that's a lot to wrap my head around. It's like science is this constant back and forth between trying to understand the world objectively and being influenced by the values and perspectives of the people doing the science.
That's a great way to put it. What's exciting about SSK is that it embraces that complexity.
Right.
It recognizes that science is a human endeavor,
Yeah.
with all the messiness and ambiguity that entails.
Okay, but doesn't that make science seem less trustworthy? Like if it's all influenced by social factors, how can we be sure we're getting to the truth?
That's a valid concern.
Yeah.
But I believe acknowledging the social dimension of science actually makes it more trustworthy,
Okay.
not less.
Okay.
Because when we understand how social factors influence scientific knowledge,
Right.
we can be more critical and discerning in evaluating that knowledge.
So it's not about throwing out science altogether. It's about being more aware of the context in which it's produced.
Exactly. It's like when you read a news article.
Right.
You don't just take everything at face value, right?
Yeah.
You consider the source, the author's perspective, the potential biases involved.
Yeah.
We should apply that same critical lens to scientific knowledge.
I like that analogy. Understanding the social and historical context of science actually helps us become more informed and empowered consumers of scientific information. We can ask better questions, identify potential biases, and ultimately make more informed decisions about what to believe and how to act.
That's the goal.
Yeah.
And I think that Heidegger's philosophy offers a really valuable framework for understanding how this all works. His emphasis on our being in the world, on how our interactions with the world shape our understanding,
Yeah.
aligns perfectly with the insights of SSK.
This has been an incredibly insightful deep dive. I'm starting to see science in a whole new light, not as this monolithic, objective pursuit of truth, but as a dynamic and evolving process deeply intertwined with our human experience.
I'm glad to hear it. And what's even more exciting is that this is just the beginning.
Right.
There's so much more to explore when it comes to how we make sense of the world and our place in it.
I'm ready for the next level.
Yeah.
What else can you tell me about Heidegger's philosophy and how it relates to the philosophy of science?
Well, Heidegger was particularly interested in how our modern understanding of the world, with its focus on objects and universal laws, came to be.
Right.
He traced this way of thinking back to ancient Greece, to philosophers like Plato and Aristotle.
So he's saying our current scientific worldview has roots in ancient philosophy.
Exactly. Plato and Aristotle were grappling with how we can think about the world in a way that's both true and meaningful.
Okay.
They saw a connection between how we think and how the world is structured.
So they were already laying the groundwork for a scientific understanding of the world.
In a sense, yes.
Okay.
But their approach was quite different from ours today.
Right.
They saw the world as an interconnected web of relationships,
Right.
where everything had its place and purpose.
Right.
It was a much more qualitative and holistic view.
Okay, so then how did we shift to this view of the world as a collection of separate objects governed by impersonal laws?
Heidegger argues that a major turning point was the rise of mathēsis in early modern science.
Right.
Remember we talked about this earlier?
Yeah.
It's the shift towards a more specific and precise knowledge.
Right, like with the example of metallurgy and those standardized techniques for smelting metals.
Exactly. This emphasis on precision and measurement becomes increasingly important as modern science develops.
Right.
It's all about quantifying the world, breaking it down into its parts,
Okay.
and creating laws that describe how those parts interact.
So we moved from a worldview where everything is interconnected
Yeah.
to one where we try to isolate and analyze individual objects and their properties.
Precisely. And Heidegger argues that this shift has profound implications for how we understand ourselves.
Okay.
Because if the world is just a collection of objects governed by impersonal laws, where do we fit in? What does it mean to be human in a world like that?
That's a deep question. If we're just another set of objects subject to the same laws as everything else, does that mean we don't have free will? Do we lose our sense of purpose and meaning?
Those are exactly the kinds of questions that Heidegger was grappling with.
Yeah.
His philosophy offers intriguing ways of thinking about our place in this increasingly scientific and technological world.
This is getting really profound. I'm definitely curious to hear more about Heidegger's perspective on all of this. But before we go there, I have one more question about that historical analysis.
Okay.
You mentioned that Heidegger traces the development of scientific thinking back to Plato and Aristotle.
Right.
But what about all the stuff that happened in between? What about the Middle Ages? Did they have any influence on how modern science developed?
That's a great question. Heidegger actually does address this.
Right.
He argues that the Middle Ages played a crucial role in setting the stage for the scientific revolution.
Okay.
But it wasn't so much about specific scientific discoveries or theories, but more about a shift in how people thought about the world and humanity's relationship to it.
Okay. I'm intrigued. Tell me more.
Heidegger points out that during the Middle Ages, there was this growing emphasis on God as the creator and sustainer of the universe.
Okay.
This led to a view of the world as fundamentally rational and ordered,
Okay.
a product of God's divine plan.
So started seeing the world as this massive cosmic machine designed by God.
Exactly. And this idea of the world as a machine becomes really important for the development of modern science.
Right.
Because if the world is a machine, then it must operate according to specific laws and principles that we can discover and understand.
That makes sense. It's like they were starting to see the world as something that could be studied and analyzed,
No.
not just accepted on faith.
Right. This shift in thinking paved the way for the scientific revolution. Once you start seeing the world as this rational and ordered system, the next step is to figure out how that system works.
Yeah.
And that's what those early scientists like Galileo and Newton were so brilliant at doing.
This is amazing. It's like all this stuff we take for granted about science and how we understand the world is actually the result of centuries of philosophical and theological debate.
It really is.
Yeah.
And what's so fascinating is that those debates are still relevant today.
Right.
Even though we've made incredible strides in science and technology,
Yeah.
we're still grappling with those same fundamental questions about what it means to be human in a world increasingly defined by science.
Okay, so we've talked about this fascinating historical journey of scientific thought. Now I'm really eager to hear more about Heidegger's own perspective on all of this.
Okay.
Where does he fit into this larger conversation about science, technology, and our place in the world?
Heidegger was both captivated and concerned by modern science and technology.
Okay.
He recognized their immense power to transform our world,
Right.
but worried about potential downsides.
Okay, I can see how science and technology can be a double-edged sword. What were Heidegger's specific concerns?
He worried that our modern technological way of thinking could lead to a kind of forgetfulness of being.
Okay.
He meant that we get so caught up in analyzing and manipulating the world that we lose sight of the bigger picture, of the mystery and wonder of existence itself.
So we become so focused on figuring out how things work
Right.
that we stop asking why they work or what their significance is in the grand scheme of things.
Exactly. He worried that we were reducing everything to mere resources to be exploited,
Right.
rather than appreciating their inherent value and beauty.
Okay.
He uses the term inframing to describe this tendency to view the world as a standing reserve,
Okay.
just stuff to be used up for our own purposes.
And framing. I get this image of the world being squeezed into a box, everything categorized and controlled. Not a very inspiring picture.
That's a good way to visualize it. Heidegger argues that this inframing can extend beyond our relationship with nature. It can affect our relationships with each other, and even our relationship with ourselves.
So we start to see ourselves as just another part of the machine, something to be optimized and used. That's a pretty bleak outlook.
It can be.
Yeah.
But Heidegger wasn't just pessimistic.
Okay.
He also believed there was a way out of this inframing,
Okay.
a way to recover a more authentic and meaningful way of being in the world.
Okay. I'm ready for some hope here. What's the way out?
Heidegger believed that art and poetry offered a way to break free from this purely technological way of thinking.
Okay.
He saw them as ways to encounter the world more directly and immediately,
Okay.
unmediated by our conceptual frameworks and technological devices.
So art helps us see the world with fresh eyes, to appreciate its mystery and beauty without trying to reduce it to data points or equations.
Exactly. Engaging with art can help us recover a sense of wonder and awe,
Right.
a sense of our place in the grand scheme of things. Heidegger believed this kind of experience could help us live more authentic and meaningful lives, even in a world increasingly dominated by science and technology.
This gives me a lot to think about. So it's not about rejecting science or technology entirely, but finding a way to integrate them into our lives in a way that doesn't diminish our sense of wonder and appreciation for the world.
That's a great way to put it. And I think that's a crucial message for us today.
Yeah.
We're living in a time of incredible technological advancement, but we also face serious challenges like climate change and social inequality.
Right.
If we want to address these challenges successfully, we need to engage with science and technology in a way that's both responsible and humane.
This deep dive has been truly eye-opening. I've learned so much about the history of science, the
Yeah.
philosophy behind it, and even about myself.
I'm thrilled to hear that. I think today's discussion highlights a really important point.
Yeah,
Science isn't just this abstract pursuit of knowledge. It's deeply intertwined with our values, our beliefs, and our understanding of what it means to be human.
absolutely. Recognizing that interconnectedness helps us have more informed and nuanced conversations about the role of science in our lives and in our world.
And who knows, maybe those conversations can even guide us toward a more just, sustainable, and fulfilling future. Something to ponder as we wrap up our deep dive.
Yeah, definitely food for thought. Until our next deep dive, keep questioning, keep exploring, and keep that sense of wonder alive. Thanks for listening.